Ladies and gentlemen, please welcome to the stage a representative from Lockheed Martin.
Good morning, everyone. My name is Eric Smith. I'm a senior principal for AI strategy at Lockheed Martin Space. And today we're going to look at a very narrow slice of AI applications, mostly for aerospace. So a quick reminder, what is AI? I think everybody at this conference knows, but a quick reminder of what that is. AI is nothing more than the capability given to machines or computers to take actions or make decisions that would normally require human intelligence. And that includes things like looking at imagery or traces of signals to identify objects. With those objects, understanding the concept of normalcy, what patterns constitute normal behavior, and therefore what's an anomaly. And if I understand a concept of normalcy, I can perhaps predict what's going to happen in the future. So being able to look a little bit forward into the future with AI. And then if I understand an action and outcome relationship, and I understand how to predict the future based on current events, I can improve my improve my ability to make decisions. And the one area that I think AI probably has a whole lot of growth, particularly when it comes to application to defense, is the ability to operate in new environments. Conflict is all about new environments. There are wartime modes that we know are going to be exposed at the very last minute that have to be responded to, in that moment. So to kind of orient folks to what a battle space scenario might look like, this is what we call an OV1. It's a fairly simplified version of what it's kind of a pictorial depiction of what's happening in the battle space. Red items here, again, just for your orientation, red items are adversarial assets, blue items are allied, and it's a fairly simple scenario that we've got here. It's detect, locate, track, destroy a surface group. Pretty simple. On the left-hand side, I have a kind of a simplified version of how it's done today, entirely controlled, essentially by humans in the loop. And whether we have AI or humans or not, it always starts with the human commander's intent, and it ends with humans acting on the course of action. On the right-hand side, I've shown how we can take pieces of autonomy to augment that decision-making process. So we always start again with the commander's intent, and then we decompose that into intelligence needs. In order to carry out that commander's intent, we need to know something about the environment. So what is that? And how do we break out those intelligence needs into sensor tasks and sensor plans? And as you can see, we're relying on a number of different platforms here, what we're calling national. That can come in many different modalities, commercial, tactical. So we're asking a bunch of different sensors to take data from different modalities, IR, RF, whatever it might be, in different time slices, so that we can build what we call a world model of what's happening on the ground. So sensor data comes in, and now we have to fuse that to build that one world model, and develop courses of action that then, again, go to the human operator. So for folks who are wondering where in that OODA loop, observe, orient, decide, act, where in that OODA loop they can contribute to the defense mission, my recommendation is look in that augmented path that we have for AI to add value. Now, in a scenario like this, where, admittedly, it's very simplified, but in a scenario like this where we have slow-moving surface targets and maybe one or two ballistic missiles to deal with, the current state-of-the-art is enough to completely handle that situation. When we get into a situation where timelines are compressed because we have a large number of, say, highly maneuverable hypersonic threats, that AI component that's added to that OODA loop is critical. All right, so we'll have one level down of what's actually needed in that OODA loop. So it all starts with what we all know and love, ATR, automatic target recognition. But again, in the defense scenario, it's really not about an image or a signal trace and identifying that there is an object in there. We have to take multiple modalities from multiple platforms in different time slices and fuse that data in a way that we know that, for instance, we're not just looking at a truck, we're looking at the truck. And that requires a very robust process for data fusion. I wanted to throw a super resolution in there. In my circles, at least 9 or 10 years ago, there was a lot of discussion about whether neural networks for sharpening imagery was really required. I mean, it's just a neural network that understands how to map a blurry image to a sharp object, and that's, shouldn't that be part of what's going on in the latent space of a normal ATR network? Shouldn't I learn that sharpening as part of the training process? But it turns out, no, that's just not true. So the sharpening on these images really does help. AI defense, so anybody who's building artificial intelligence or autonomy for use in defense applications should have another team that's working side by side who's also figuring out how to defeat that AI. And when an attack vector is discovered, the team that's building the AI that's going to be deployed should not only be able to be robust against that attack, but understand that the attack is being levied against them. So it's certainly not enough to field a system that is robust in operation, but understanding that the adversary knows enough about what you're doing to try and attack you in a way that you've already discovered is important information. So having those dual teams is important. And working at the edge, again, when we get into a compressed timeline scenario where fast sensing and decision making is of the essence, highly maneuverable hypersonic weapons as an example, having all of this operate at the edge is incredibly important. So then one layer up from your object detection is change and anomaly detection. And again, for folks thinking about how to take their AI or autonomy that's looking at object detection and change detection based on objects, it's more than just saying the number of objects in a particular area of interest is different, or there was something here and now there's not something there. It's got to be really based on context. So it's starting with the commander's intent. I want to know when a particular aircraft or truck or mobile missile launcher goes from area A to area B. It's really got to be rooted in the context of the mission. And the activity recognition and event forecasting. This one, there's just so much that can be researched and there's just a lot of gold to mine in this one. I mean, I think about the surprise attack on Russian aircraft from Ukraine. So if we had the ability to play that movie in reverse, we would probably see those semi-trucks doing things that were a little odd, a little unexpected. And had Russia had the benefit of knowing that a certain group of trucks were making stops that were very unusual in unusual places and staying there for an unusual amount of time and taking these weird paths across the border headed toward airfields, they probably wouldn't have been able to say, I know what's going to happen, but there would have been enough red flag there to say, maybe we ought to take a closer look. And of course, it's easy to say, well, you can pick out this one already known, already, having taken place event and point to that as something that as an example of where AI can help in terms of adversarial, um, understanding adversarial behavior. But the world is very large. World is very complex. There's so much data there. But that's exactly what neural nets are really good at. So again, for folks wondering, where might I put my my data analytics skills to use for the government? I think that's another area of the predictive analytics, looking at the entire body of information available to you and understanding what's normal and what's not, and where to apply those flags. And of course, at the very top level, it's optimizing the entire space operations, which we would call, say, intelligence orchestration. So if we're not talking about targeting, I would argue that we don't really care about something like ATR. And some people might argue with that, but what we really care about is intelligence, information and intelligence. And historically, we've tied that very tightly to knowing what objects are where, but in the end, it's just the intelligence piece. So what we'd like to be able to do is not task platforms to collect objects. We want to task constellations to gather intelligence. And so that's kind of the highest level of autonomy that we are interested in. I'm going to jump down to the last point, the adaptive communications. There's rightly a ton of effort going on in terms of securing our networks. We know that in a conflict scenario, the first thing that's going to be targeted is the communication network. Your adversaries will want to blind and isolate your forces, making them essentially completely ineffective. And it's not enough to secure the network. One has to also have an ability to work around a compromised network. And we know that generative AI is going to be used as one of the attack vectors. And so for folks, again, wondering where to apply AI in the communication space, from my perspective, it's think about how to use generative AI to come up with interesting defenses and workarounds for interesting attacks that adversaries are going to come up with. Flash Tracker, this is kind of an interesting civil use case. Again, super useful and a lot of room for growth here for folks. Flash Tracker is an AI-based capability that allows us to look at a bunch of environmental variables, fuel loads, terrain, wind speed, temperature, bark beetle infestations, how much dead wood is there in a particular area, and overlay that with a live map of lightning strikes to inform commanders on the ground about where they should be concerned about a wildfire occurring. And so we generate this heat map of probabilities of ignition for commanders then to develop their courses of action. And you might say, well, I mean, lightning struck, why don't you just go look and see if there's a fire? But it turns out these fires can smolder in a way that are completely unseen. Unless you go with a shovel or an axe, you're not going to discover that there's a smoldering fire, and they can last for days or weeks or months before they erupt. So Flash Tracker. I'm not going to brief this chart. I put it up here for to call attention to the panel on the right-hand side. So this, summary. A Colorado field pilot said, "Thank you for working with us shoulder to shoulder with our operators to understand how to integrate Flash Tracker into our workflow." So again, if you're looking for opportunities to work for or with the government on AI applied to their workflow, to their trade craft, you've got to sit with your customer. You got to understand where they actually need help, what their real constraints and interfaces are, what their trade craft is, to know how to apply your technology in a way that's actually going to transition. Let's see, I've only got a minute left, so I want to go to the kind of the ultimate and unknown scenarios, and that's deep space exploration. One of the most fascinating bodies in the solar system from my perspective is Europa, one of Jupiter's moons. Kilometer thick sheets of ice floating on a liquid ocean, liquid warm ocean that may hold life. But you're talking about a moon that is a 45-minute one-way trip for a photon, completely impossible to do remote operations in a case like that, particularly when you drill down through this kilometer thick sheet of ice and discover a completely unknown world that you have to interact with. So building autonomous systems that understand how to interact with and learn from these new environments, again, is an area of a lot of discovery, So that's my time. Thank you very much.